I need to state right at the very beginning that this broadcast is an AI-generated analysis. But imagine staring at a blank screen, typing just a single comment describing what you want, and then watching an artificial intelligence write your entire back-end architecture in, like, 3 seconds.
I mean, it's practically magic, honestly.
Right. It feels like magic. But today, we're unpacking exactly how that magic actually works. Welcome to our comprehensive analysis of the core technical concepts in the book Learning GitHub Copilot by Brent Laster.
Yeah, I'm really excited for this one.
Me too. Today, our mission is to, move past all the hype. We aren't just going to list features. We want to look under the hood at the underlying logic.
Exactly. We're mapping that massive technological leap from basic inline code completion to these autonomous multi-file AI agents that can just refactor a whole project on their own.
Which is wild.
Yeah.
But before we get there, we've got to set some ground rules for this detailed technical review. We'll be sticking strictly to the technical mechanisms from inline processing all the way to agent-driven editing. And we're going to translate these really complex operations into clear language so it's accessible for you as you listen.
Because it really is a massive paradigm shift. But, to understand how we got to autonomous AI agents, you really have to start by analyzing the fundamental engine first.
The engine driving those generative code suggestions inside your IDE, right?
Right, the integrated development environment. And the very first thing to understand about GitHub Copilot is that its architecture is fundamentally cloud-based.
So the heavy lifting isn't actually happening on your laptop.
No, not at all. Copilot requires a local IDE, like Visual Studio Code, to basically function as its sensory interface.
A sensory interface. I like that.
Yeah, your local environment just captures your current state, like what you're typing, what files are open, and then it communicates constantly with the cloud infrastructure. That's where the large language models actually live.
Which brings us to the most common way you interact with it, the standard inline workflow.
Right, the ghost text.
Yeah, exactly. If you've used it, you know the rhythm. You type a segment of code, you pause, and you review that gray ghost text that pops up on your screen.
And then you have a choice.
Right. You can accept the suggestion fully, or, you can accept it partially, word by word, if you just want a small piece of it, or you just keep typing and discard it entirely.
But I think we need to zoom in on that pause.
Yes, let's talk about the pause.
Cool.
Think about that split second when you stop typing. It feels a lot like a background compiler, right? Like one that is frantically trying to anticipate your syntax and logic before you even execute anything.
That's actually a highly accurate way to visualize it. During that brief fraction of a second pause, there is just an incredibly complex sequence of events firing off in the background.
So what's actually happening that split second?
Well, your local extension is gathering the immediate context from your open file. But, and this is key, it doesn't just blindly send your whole file.
No, it doesn't.
No, it synthesizes the data around your cursor, packages it, and then transmits it across the network to query the large language model.
Wow.
And concurrently, it's actually running safety checks, too.
Wait, really? Safety checks in that fraction of a second?
Yep. It checks for patterns indicating security vulnerabilities. And it matches the generated code against public repositories, just to ensure it's not simply regurgitating copyrighted code verbatim.
Okay, but here's where I get hung up on the mechanics a bit. If I open a brand new file, the context is incredibly sparse. I mean, I might just have one line of code.
Right.
So how does the underlying model resolve the ambiguity when it has almost nothing to go on? How does it predict my exact intent?
Well, the short answer is it doesn't.
It doesn't.
No, it doesn't actually predict your exact intent. It relies entirely on the non-deterministic nature of generative AI.
Okay.
Remember, these large language models are fundamentally just prediction engines. They're calculating the probabilities of the next sequence of tokens. So when your context is really sparse, those probability paths diverge wildly.
So it's guessing based on math.
Basically, yeah. The model resolves this ambiguity not by making a single definitive choice, but by calculating different probabilistic branches.
Okay, can you give me an example of that?
Sure. So if you type at the beginning of a function, say def calculate total, the model might calculate that the next most likely token is a quotation mark, which leads it to offer a docstring comment explaining what the function could do.
Right.
But an alternative, equally probable branch might offer the complete programmatic definition of that function, complete with tax calculations and everything.
I see. So it's basically playing out multiple futures at once, and it's just showing you the one that mathematically won the coin toss at that exact millisecond.
Exactly. And because it's non-deterministic, if you provide the exact same sparse context at a different time of day, you might get completely different suggestions.
Just based on minute variations in the model's probabilistic generation.
Exactly.
Okay, so that passive inline suggestion is amazing for boilerplate stuff, but it obviously can't read your mind for complex logic.
No, definitely not.
If you want the AI to do something specific, the workflow logically demands a method for active, explicit instruction. Passive just isn't enough anymore.
Which brings us to the chat interface.
Yes, and the critical concept of context management. Because to actively communicate your intent, you have to use specific chat participants.
Right, these are basically boundary markers, like at Workspace, at VSCode, or at Terminal.
Because if you just ask a generic question in the chat, the AI doesn't really know where to look.
Exactly. By typing at Workspace, you are explicitly setting the scope. You're telling the model, hey, apply my query to the context of this entire repository.
And if you use a terminal,
Then you're restricting its attention purely to the command line output, which, by the way, is brilliant for debugging an obscure build error you just got.
oh, I bet. And it goes a step further with slash commands, too. So instead of typing out a long prompt like, please read this code and tell me what it does, you just use predefined templates.
They're huge time savers.
Yeah. You can use explain to analyze dense code, fix or resolve errors, tests to generate unit tests, or doc to write documentation. It feels like these commands are essentially injecting an invisible system prompt behind the scenes, right? Like to force the model into a specific operational state.
That is exactly what is happening. The slash command instructs the model to apply a specific operational template to your query, so it bypasses the need for you to engineer the prompt perfectly every single time.
But to make these commands truly powerful, the book points out that developers have to master chat variables.
Yes, this is crucial. This is where you use the hashtag codebase variable or specific hashtag file selectors to manually target the context.
So you don't have to rely solely on the automated repository indexing provided by GitHub.
Right. You can explicitly say, look hashtag filebackend.py and fix the routing error.
Let me make sure I'm wrapping my head around this context targeting. If we apply an analogy to standard programming concepts, is utilizing the hashtag codebase variable basically akin to declaring a global variable,
Okay, yeah.
whereas using a hashtag file selector acts as a strict local scope constraint.
That is actually a perfect analogy. Utilizing hashtag codebase forces the system to query the automated workspace index. You're effectively treating your entire repository as a global data space.
Which relies on semantic search, right?
Exactly. It uses semantic search to find relevant code snippets across all your directories before it synthesizes a response.
Right.
It is powerful, but it can be noisy.
Because it's pulling in everything. I mean,
Yeah.
it might grab a legacy file you haven't touched in 3 years.
Precisely. Conversely, the hashtag file selector acts as that strict local scope constraint. It restricts the AI's context window exclusively to the contents of the specified file or files.
So it prevents the model from diluting its attention with irrelevant data from the broader repository.
Exactly. This local scope is critical when you need precise modifications within a single structural component. You are artificially narrowing the AI's focus to reduce token noise.
And you can actually bypass these defaults if they get in your way, right? Like
Yeah.
if the system automatically assumes you want to talk to a workspace but gets it wrong,
Yeah, you can use the rerun without feature, or you can just change your submission behavior.
like using a standard send versus send to at workspace in the interface.
Right. That directly alters how the query is resolved. It really puts the responsibility on the developer to manage the AI's attention span.
Which is such a crucial skill now. The AI is incredibly smart, but its memory and attention are highly dependent on how well you curate its context window.
Yeah.
Okay, so we've established how to actively query the AI and set its scope. But here is where the book gets into the truly mind-bending territory.
Yeah, the autonomous stuff.
Exactly. The next technological progression is delegating multi-file structural modifications directly to the AI. We're talking about a paradigm shift from simple generative text suggestions to autonomous editing. And the system breaks this down into 3 levels of advanced scope.
Yes. So the first level is Next Edit Suggestions, or NES. This automates single file changes based on the immediate trajectory of your current edits.
So if I change a variable name on line 10,
The AI anticipates that you'll need to change it on line 40 and 60, and it just offers to do it for you. It's basically predictive editing.
in the second level,
That's Copilot edits. This manages multi-file project sessions. You can prompt it to make coordinated changes across several files simultaneously.
But the highest level, and the one that really feels like the future, is Copilot Agent Mode.
Oh, agent mode is incredible.
It provides autonomous execution from your initial prompt all the way through to the finished implementation. To illustrate this, the book walks through a fascinating example of building a Python Flask calculator application.
Right, I remember that.
In this scenario, the developer instructs the agent mode to enhance a basic functional web calculator, and the agent doesn't just dump code into the chat. It formulates a step-by-step plan. It updates the content inline across the Python backend and the HTML frontend.
And what's truly remarkable about that specific example is the iterative reasoning. During the process, the agent independently identified a division by zero vulnerability in the logic.
Wait, it wasn't explicitly prompted to look for security flaws?
Nope. It just realized that the math logic it was writing could crash the application, and it proactively implemented a safeguard to throw a clean error instead.
Well, that is insane.
And it also iteratively corrected a web application display issue where the numerical results were not rendering correctly on the front-end interface. I mean, it acted like a senior developer reviewing its own work.
And it gets even crazier. The text introduces Copilot Vision, which allows the AI to interpret visual data.
This part blew my mind.
Same. In the book, the developer provides a visual reference, literally just a screenshot of the standard calculator interface. The AI analyzed the pixels of that screenshot and mapped the visual operator symbols to their corresponding operation names in the back-end logic.
Right.
It automatically added an exponent function, represented by 2 asterisks in Python, simply because it visually recognized an exponent button in the screenshot, even though that function was not originally coded in the base application.
It's literally translating raw pixel arrangements into semantic meaning and then translating that semantic meaning into functional back-end logic. It completely bridged the gap between user interface design and software engineering.
Okay, but I have to question the boundaries of this autonomy. Because at what point does Copilot Vision risk misinterpreting a visual cue?
That's a very fair question.
What if I have a purely stylistic element on my screen, like a decorative graphic or a company logo, and the AI confuses it for a functional button? Furthermore, if it's running autonomously, what is the exact mechanism for you, the developer, to intervene in this iterative loop when the agent begins executing a fundamentally incorrect plan?
Well, that is the core challenge of autonomous agents. The risk of visual misinterpretation is, inherent to the computer vision models underpinning the system.
Right.
If a decorative graphic shares the geometric properties or text layout of a functional user interface component, the vision model will probabilistically classify it as functional. It will absolutely try to generate corresponding back-end logic for a logo.
Which would be a disaster in a production code base.
Exactly. And the mitigation for this risk lies entirely in the developer intervention mechanisms.
Okay, how does that work?
The agent mode does not commit code directly to your production branch. It operates within an iterative loop, presenting a visual comparison of the proposed changes.
Ah, so you can see what it wants to do before it does it.
Precisely. You utilize the keep or undo interface controls to review each individual step of the plan. If the agent misinterprets a styling element, you just select undo, and then you modify the text prompt to explicitly exclude that visual element from the functional requirements. You are the guardrail, basically, guiding the agent back to the correct probabilistic path.
That makes sense. It's an assistant, not a replacement. And that actually transitions perfectly into the final phase of the development lifecycle.
Right, quality assurance.
Because once the code is generated and autonomously edited, you still have to maintain strict verification. If the AI can write the code in seconds, it also needs to automate the traditionally manual burdens of testing and documentation.
Testing is a big one.
Let's talk about testing first. The automation of test generation uses the test command. And what I love about this is how it fundamentally supports test-driven development, or TDD.
Oh, yeah. TDD is notoriously difficult for a lot of developers to stick to because, writing tests before the logic is tedious.
It's a chore.
Exactly. But with Copilot, you can write the definition of a required function, immediately utilize the test command to generate the unit tests based purely on the function signature, and then subsequently prompt the AI for the actual implementation that will satisfy those generated tests.
It flips the friction of TDD on its head.
It really does.
And the system also drastically reduces the burden of documentation. The book highlights how the AI distinguishes between generating structural documentation and functional documentation.
Right. So, by using specific hashtag file prompts, you can instruct the AI to generate structural documentation, like Swagger API
It
specifications.
is super technical, right?
Very. It details the highly technical endpoints, parameters, and return types. It's rigid and meant for other systems or back-end developers.
Okay, and what about functional documentation?
Alternatively, you can request functional documentation, which is presented in a flowing prose format. It's designed for external users or product managers to understand the practical application of the code without needing to read or comprehend the underlying syntax.
Beyond writing documentation for new code, the AI possesses this incredible ability to explain dense, auto-generated boilerplate code that you might have inherited.
Yes, the book gives a really specific example of this.
The Kubernetes one, right?
Exactly. Explaining a Kubernetes custom resource file. The file is named zyzigenerated.deepcopy.go. Most developers look at that and just glaze over,
I would.
but the AI decodes the naming conventions. It explains that the Zeiss prefix is actually a deliberate convention designed to force the file to the absolute bottom of alphabetized directory listings.
Just so humans don't have to look at it.
Yeah, and it clarifies that the code provides deep copy functions for custom resource types in Kubernetes. It acts as an incredibly patient senior engineer.
That's a great way to put it.
In fact, another highly effective application highlighted in the source is utilizing Copilot directly as a teacher. You can prompt the AI to generate coding problems for you, along with the subsequent solutions, to facilitate learning a completely new programming language entirely within your IDE.
So you don't have to bounce back and forth between a tutorial website and your editor.
Exactly.
It's brilliant. But let's apply an analogy to that documentation generation process. The way Copilot generates documentation is highly comparable to reverse engineering a compiled binary back into a human-readable specification document.
Oh, I see what you mean.
The model observes the structural logic, follows the execution paths, and synthesizes the human intent behind it.
That's a really great way to think about it. It maps the output back to the intent.
But I must push back on the ultimate reliability of this feature, because if it's just reverse engineering what is already there, can the artificial intelligence accurately document a fundamentally flawed architectural pattern? Or will it simply generate highly professional-sounding rationalizations for incredibly bad code?
Yeah, that is a crucial limitation, and every developer needs to acknowledge it. The model is fundamentally designed to describe what the code does, not to pass architectural judgment on whether the code is optimally designed.
Unless you explicitly ask it to.
Right, unless you explicitly prompt it to critique the architecture. Therefore, if you point the model at a fundamentally flawed spaghetti code architectural pattern, the AI will indeed generate highly professional, perfectly coherent documentation that elegantly rationalizes your poor implementation.
It reverse engineers the logic exactly as it is written, flaws and all.
Exactly.
So it will confidently explain why your terrible database query is actually a feature, not a bug.
Yep. And this reinforces the overarching principle of the entire book. While AI automates the mechanical generation of text, the human engineer must retain the responsibility for verifying the structural integrity and quality of the underlying design.
The AI is a powerful engine, but you are still steering the ship.
Exactly.
Let's summarize the logical trajectory of our comprehensive analysis today. We began with the foundational cloud-based mechanics of inline generation. We explored how the system relies on large language model probabilities to anticipate your syntax during a simple fraction of a second keystroke pause.
And then we advance to the necessity of active context management.
Right, looking at how developers use chat participants, /commands, and file selectors to define specific targeted boundaries for their queries, essentially controlling the AI's attention span.
From there, we explored the high-level automation of multi-file editing. We move from simple autocomplete to the autonomous Copilot agent mode, which can, plan and execute complex refactoring across front-end and back-end systems.
We even saw how Copilot Vision interprets raw interface screenshots to generate functional back-end logic. And finally, we concluded with how this technology automates the verification process through test-driven development and automated documentation.
While cautioning that the AI will happily document bad code if you let it.
Which leaves you with a really profound final thought to mull over. As we observe these models gaining increasingly autonomous execution capabilities, moving from just guessing your next word to planning and executing multi-file refactors, we are witnessing a fundamental transformation in the discipline of software engineering itself.
It really is a transformation.
As the mechanical burden of typing syntax and generating boilerplate is entirely absorbed by artificial intelligence, The cognitive load of a software engineer will inevitably shift. If the AI is doing all the typing, what does it actually mean to be a programmer 5 years from now?
That's the million-dollar question.
Are you still a coder? Or are you transitioning into an editor and auditor of machine thought? Your primary daily function is shifting from the manual composition of text to strictly validating, auditing, and guiding algorithmic logic. It's a whole new world.
It truly is. The skills that make a great developer tomorrow will be very different from the skills that made a great developer yesterday.
We strongly recommend that you read the actual book, Learning GitHub Copilot by Brent Laster, to achieve further technical mastery of these concepts. There is so much more in there regarding specific implementations and workflows.
Highly recommend it.
To all the friends of the show listening today, we encourage you to subscribe to the broadcast for future comprehensive technical analyses. Thank you for joining us on this journey, and we wish you a great day.